Welcome to the probability video part 2. So continuing through our examples here. In a long distance foot race, how many different finishes among the first 5 places are possible if 50 people are running? So once again, there are no repeats here. Because if someone places first, they do not go back in the pool. They place first and they're only first. Then there are 49 remaining contestants. Now, this is the one where order does matter. Because if you actually have places, that means first is different than second, which is different than third, as opposed to we are just looking at the first. If we were just looking at 5 people out of 50, then order would not matter. But since we're talking about a race, right, it is a big difference between first and fifth. So if you have no repeats and order matters, that means we are looking at permutations. All right. Now, using our same notation, we have 50 people, and instead of NCR, NPR. 50 permute 5. In our calculator, 50 over to PRB and NPR 5. Enter. And that gives us our permutation, which I'm going to transform into scientific notation. 2.54 times 10 to the 8th. The winner of a raffle will receive a 30-day all-expense-paid trip throughout Europe. Oh, that's lucky, huh? 5,000 raffle tickets were sold, and you purchased 30 tickets. What are the odds against your winning the trip? Okay, so multiple ways to do odds. Odds is very, very similar to probability, okay? Odds is very, very similar to calculating probability. It's just another way of displaying the information. So I prefer to always identify the probability of something happening and then identifying the odds. Specifically, let's identify the odds of winning the trip. So probability of W, winning. Well, if we bought 30 tickets and there are 5,000 tickets possible, your odds of winning are clearly just 30 out of 5,000. Since we're doing odds, we need to reduce this. So I'm going to divide this both sides by 10, just reduce this. This becomes 3 out of 500. It's actually pretty good odds, right? So this means the odds for are the possibilities that this happens is 3, and the number of possibilities this does not happen, which is the remaining 497. A common mistake with odds is people believe that this should be the denominator, but this value plus this value makes the denominator. All right, there are 500 possibilities total. That's how odds work. 3, it does happen. 497, it does not. Then in order to find odds against, simply flip it. 497 to 3. You actually should be very, very familiar with the odds wording, right? Odds against something happening, oh, that's 5 to 1, right? That would be like a number on a die. So, like I said, some people go straight to this. That's absolutely fine, all right? If you get confused, I recommend using the full process here. Biggest thing is always odds need to be reduced. So this should not be the full 30 over 5,000, but always reduce your probability to the lowest denomination first. And if this could go any lower, I would, keeping it whole numbers, that is. All right, so Suppose a study was conducted at a university to see where students prefer to shop. For grocery stores, 1,000 students selected. We have 3 grocery stores selected, and we have freshmen to seniors and graduate students in the study. Then from this, we can answer all kinds of questions. So just as a note, the graph initially only had this information. I summed everything to, again, just to save us time. Your very first step with all tables is to sum everything column-wise and across the rows. So I've identified the sums, all right, in the columns and the rows, and then the overall total, which is 1,000, to verify the number of students in the study. Then, once you have all that information identified, then you can proceed to answer questions. But again, everything in probability is about setup. Make sure you set everything up. Take your time and setup, and the questions will flow very, very smoothly. So, what is the probability that a randomly selected student prefers to shop at Walmart? So, probability, W, using the notation presented to us, and then that's just the column total, which is 323, out of the overall total, 1,000. And it's perfectly fine to leave it like that. Or again, you can turn it into its decimal, or you can write it as 32.3%. It does not matter. All of those are equivalent, whichever is easiest for you. I tend to even leave them in the unreduced fractions, just because to save time. What is the probability that a randomly selected student is a junior and prefers to shop at Albertsons? So probability junior and Albertsons. And then that means matching up Albertsons and junior, all right, identifying inside the table, and that's 75 out of everybody. Find the probability a randomly selected student prefers to shop at Albertsons or is a senior. So probability Albertsons or, all right, and now just as a note, all right, or a senior, that means are, given the notation. If notation is already defined for you, be sure to stick with it. Which gives us or are. And there are multiple ways to do this, all right? There are 200 seniors and 262 that go to Albertsons. So we could, excuse me. And it is out of everyone, so it's out of 1,000. So 200 plus the 262, but, all right, 200 seniors and 262 to go to Albertsons, but I double counted this 35. All right, because I counted it in the 262 and in the 200, so I'm going to subtract it out once. And that gives me 427 all out of 1,000. Like I said, there's multiple ways. You can also just do it by 110 plus 55 plus 40 plus 54 plus 75 plus 35 plus 58. You could do it that way too. Multiple ways. There's always multiple ways to do a problem. All right. What is the probability that a randomly selected student is not a junior and does not prefer to shop at Walmart? So probability not a junior and not Walmart. So once again, all right, when we look at this, we identify that means they are not, we don't want this area, all right, and all right, we don't want Walmart. So basically we are not counting these people. And so again, sometimes it's easier just to go through these piece at a time. All right, this person, right, is neither of those. All right, so it really means I'm looking at that person, this person, this person, this person, this person. Oh, whoops, not Walmart, sorry. That person and that person, that person and that person, that person and that person, that person and that person. All right, so the 40, the 95, the 54, the 70, the 35, the 110, the 58, and the 60. If we add all those up, now again, this is a complicated one because we don't want that entire column and I don't want that entire column. There is no actual fast way to do this. You have to just think about what you are looking for, all right? When you sum all those up, all right, 40, 54, 95, 70, 35, 110, 58, 60, all right, you should get 522 all over 1,000. And again, there is no quick way to go about that. All right. Suppose a randomly selected student prefers to shop at Albertsons. What is the probability that he or she is a sophomore? So finally a different change in the question. Once again, this word suppose, we've seen that before. That is another way to say given. Given. All right, the student prefers to shop at Albertsons. So probability given. Always start with your given statement. Albertsons. What's the probability that he or she is a sophomore? So that means sophomore given Albertsons. Then, all right, now I can use the definition of conditional probability that we identified before. Probability of S and A all over the probability of A. But the nice part about tables is I can actually identify this just by looking at the table. We identified the person prefers to shop at Albertsons, which means I'm only looking at the top line here, which means that is my denominator. I'm only looking at 262 people. Then, where are the sophomores? 54 out of 262. And it's that simple. Tables actually are even easier to identify conditional probabilities than Venn diagrams because the information is laid out so well. All right, lots of other questions to do. This is, again, just to get you started and help you out. I hope this was helpful, and as always, good luck and have fun.